Okay, so welcome to problem 7. Problem 7 is about the ideas of position, velocity, and acceleration, and how they can all be functions of time, and possibly even arbitrary functions of time. But those functions are related because if we know x as a function of time, then the velocity is dx dt, and the acceleration is d squared x dt squared, the second derivative of x with respect to t. So in this problem we are given an arbitrary position of an object over time, which is given by the formula seen here. X of t equals negative 6.8 meters per second times t plus 4 meters per second cubed times t cubed minus 1 meter per second to the fourth times t to the fourth. And we aren't given any information about what kind of object this is or why it follows this this kind of strange position as a function of time. But nevertheless, without any of that information, we still are able to calculate the velocity and acceleration just by knowing the definitions and some calculus. Nevertheless, we're able to calculate the velocity and the acceleration as long as we know the position as a function of time, because we know these relations, the definitions of velocity and acceleration, and we know calculus. So part A says, based on the equation, what is the velocity over time? So what we need to do here is, given this equation for the position, take the derivative, and we get negative 6 meters per second, plus we get a 3 times 4 meters per second cubed times t squared, minus 4 times 1 meters per second to the fourth times t cubed. And we can multiply these through to simplify. So we get v of t equals minus 6 meters per second plus 12 meters per second cubed times t squared minus 4 meters per second to the fourth times t cubed. Okay, part B asks for the acceleration as a function of time. Now we know the acceleration is just dv dt, or the second derivative of x with respect to t. So now we just take the derivative one more time, and we get, well, this term goes away because it's a constant. We get 2 times 12 meters per second cubed times t minus 3 times 4 meters per second to the fourth, and this has a t squared next to it. Okay, so now if I multiply these through, what I get is 24 meters per second cubed times t minus 12 meters per second to the fourth times t squared. So that's a of t. And I box these because these two are my final answers for A and B. Okay? Now part C asks, based on the graph given in the problem of x as a function of t, qualitatively sketch v of t and a of t. And so now I have these equations, I basically just need to sketch them, but probably easier than just sketching an equation from scratch is looking at this diagram and qualitatively figure out what I expect in each region. So for example, here at early times, it looks like x is decreasing, and that means we have a negative velocity. So down here we have some negative velocity. However, then it turns around and x starts increasing again. That means around here we switch to a positive velocity. So around here we have some positive velocity. Then again over here, it looks like x starts decreasing again. Then we have a negative velocity. So we have something that looks maybe like this. Okay, now for acceleration, we're really looking at the derivative of velocity. So here velocity has a positive slope, velocity is increasing, that's a positive acceleration. Actually, if you want to look at the starting point, at for example t equals 0, you can see the acceleration at t equals 0 has to be 0, so it has to start out here. But then we have this positive slope, which means we need a positive acceleration around here. And then at some point it turns over into a negative slope. So at some point we end up having a negative slope down here. So basically we get a function that looks kind of like that. And we get all that just from analyzing the graph that we're given, and we get the functions v of t and a of t from analyzing the equation that we're given. So this problem is very theoretical. There's, as I said, we don't have any details of the object, but we can learn a lot of information about it just by analyzing its kinematics.